So just as a civil engineer, you need to know what is the demand, what is the supply, right? So what I will do, I will just write down demand or outflow because that is outgoing from something, and supply, which is the inflow or input. Okay, now you tell me what is the supply here for this watershed. We are getting 60 inches of rainfall, but obviously we are not using all of those. There will be some infiltration, some evaporation and everything, but 55% of that rainfall is actually going to a reservoir for the water supply purpose. So what is actually the inflow here? What is the inflow? That 55% of that rainfall is actually the supply of this water, like the town, right? Okay, now we need to think about what are the demands that city needs to meet in water-wise. The first one is the reservoir storage is proposed to be used to satisfy 60 million gallons per day. That means that city requirement is 60 million gallons per day, right? They already gave you all the conversion factors. So this time we are not concerned about the unit conversion. Okay. Acre feet per year. Is there any other demand in that town? Is there any other demand other than that 70 million gallon per day? Read the question. Right now, 0.5 cubic feet per second. In addition to that 70 million gallon per day, they have an in-stream flow requirement also, which is 0.5 feet cube per. Oh, I don't need to write down that one. Okay, so that will be 360 acre feet per year. So now we have demand, we know the supply, we just need to check if the supply is enough for meeting the demand or not. So how can we do that? Yes, yes. So we will just compare the total values of demand and compare the value like with the total value of supply, right? So let's do that. If we get positive number, that means the supply is higher than the demand. So we should be fine. If not, then you will make the recommendation. Okay, the supply, natural supply is not enough. The CD needs to find another source, right? Okay, let's work on that. Are we good up to this point, everyone? Okay, so supply or inflow, demand, outflow equals to the change in storage. We know that over time, right? So the inflow is what? Oh, we didn't actually calculate that one, right? 0.55, 60 inch per year. And what are the demands? 78,439 plus 362 acre feet per year equals to change in storage over time is delta S. So I will just write down delta S. Now we can't compare with the values with two different units, right? We need to convert that into the same unit. So let's convert that inch per year into acre feet per year. How can we do that? The first thing is we need to convert from inch to feet. So we will divide that by 12, right? And how can we get the acre one? Like this is the just depth of the water, but we need the volume. So what we will do? Do we know any area or anything? Do we know any area on which this rainfall is coming? 32,000 acre. That is the watershed area. Now we have acre feet per year. Now let's check if we can get delta S as a positive or negative number. Okay. So give me the number. Give me the very final number. I don't need the individual in supply demand. So give me the very final number. I got something around 9,000, not exactly 9,000, but something close to that. Yes.
Where does 22,000 come from?
When, which one?
22,000.
32,000, this one?
Oh, yeah. Where's that come
That is actually, if you look at the question, it says that the watershed of size,
from?
and we had only the depth here, but the other one is volume over time. So we just multiplied it 32,000 just to get the volume of water. Okay. Does that make sense? Okay. So what number you got? 9,199 acre feet per year. That means per year that town has 9,199 acre feet of water excess water, right? So do they need any additional water supply source or not? No, right? What about the other people? What do you think? Do they need any other source or this should be enough? The natural water should be enough, right? Okay, so I will just make a note here that the town doesn't need any additional water source. Yes.
Are you saying it doesn't need water source because
That positive number means what? Supply is greater than demand. That means the demand was something and the supply was something. Your supply was 9,199 acre feet of water excess. So that's why you don't need the additional water supply. Okay. Okay. So this one was easy, right? The next one is easier theory wise, but it will take time to convert all the units and everything. Okay. So we will be careful and we need to be a little bit strategic, like which unit we should change first or not. So let's work on that one. Okay. Okay, so I will go back to class example 1. Okay, who will read class example 1? Anyone?
300 acre lake has 15 cubic feet per second of water, of surface water, so 13 cubic feet per second, distance from outflow. A total storage production of 15 acres per month.
Okay.
A rain recorded 1.3 inches in fall for the month. Velocity evaporation to that one.
Okay, thank you. So this one is kind of straightforward, like for a watershed, for a lake actually, we have the area and we know the surface water inflow, surface outflow, and the total storage reduction. At the same time, we know the total rainfall, 1.3 inches of rainfall for that month. Now, they are asking you to, since it's an open lake, there will be a significant amount of evaporation since it's a water body. To determine the loss due to evaporation for that month in inches. Now here we are not discussing any temperature, anything. We are just doing the water budgeting thing, like if we know the incoming and the final storage thing, can we calculate one outflow thing, right? So that's what we will do. The first thing first, the water budget is, or hydrologic budget is inflow minus outflow equals to change in storage over time, right? Hey, everyone can read my handwriting and it's the correct, like perfect size and everything. Okay. Okay. So change in what storage over time. Now we need to find what are the inflows we have here and what are the other known values we have. So do we have inflow here? The very first inflow is what? 50 CFS of water surface inflow. Okay. What else? Anything else we have? 1.3 inches of rainfall. Okay. So 1.3 inch per month. I will not do anything with the unit first. I will just write down as the way it is, and then we will think what should be the best way. Okay, and I don't think we have any other inflow. Now we have outflow, which is the surface outflow, right? 13 CFS. At the same time, since they are asking you to find loss due to evaporation, that is another outflow, right? And do we know the change in storage over time, which is the total storage reduction, 15 acre feet per month. When it says the storage reduction, that simply means the evaporation and the surface outflow was actually higher than the incoming flow. That's why the storage is getting reduced, right, over the time. Okay, now we have everything in multiple different units. So we need to find out what is the best way to do the very final answer. Okay, so we need to find evaporation in which unit? Month in, like inch per month, right? Are you seeing that? Loss due to evaporation for that month in inch. That means it should be inch per month, right? So as a first step, what we can do, we can change all the time unit into month. We already have 1 month, but this one is CFS, this one is CFS. So let's change the second into month. Okay, let's do that one first. Are you good with that step? Okay, so what we will do, obviously that will be a huge, before doing that, we have 15 CFS and 13 CFS. They have the same unit. So can I write down 2 CFS so that I don't have to do twice? Plus 1.3 inch per month E 15 acre feet per month. Okay. And since we are looking for to find E, I will rearrange the equation such a way that E should be on the left side, everything else should be on the right side. Okay. So let's do that. And then I will kind of leave on your own. Just try something like how can we find it? After that, it's just the unit conversion. So I will give you a few minutes just to try out that, and then I will come here and work on the solution. Does that sound good? Okay. So I will write down one more line here, which is E equals to, okay. Maybe I will go to the next one. So E equals to 2 CFS 1.3 inch per month, 2 CFS 1.3 inch per month, and minus 15 acre feet per month, right? So that means 2 feet cube per second. So the conversion will be from second, we want to convert everything into month. So from second, we will convert that into what? In minute, right? Once we have in minute, we'll convert them into hour. Once we have everything into hour, we'll convert them into day. And once we have the day, we'll convert that into month, right? Does that sound good? Now, you may question, ma'am, why we are using 30 for month, because they didn't mention which month it is, so I don't know. So I will just use the normal 30 days equals to 1 month, okay? Okay, now you have 10 minutes, kind of, you have all the conversion, like how you can convert feet square into acre or something like that. Can you find the E, the evaporation in inch per month? Okay, I'm giving you the very final answer, but I will do that on board at the very end. The final answer will be kind of around 6 inch per month. Okay, so work on that. Ask me question if you have any. If not, I will just be here and help you. Yeah. One hint, you can actually convert that feet cube into acre, like feet square feet, and then convert that feet square into acre because you know the conversion, right? Okay, I'm writing one more line just to help you a little bit. So feet square feet month, 1.3 inch per month. And I'm seeing 1 inch here. Do we need to work with inch at this moment? Convert that to acre. Okay. Now you have more information. Try to work on that. Try to use the conversion factor between feet square and the acre. That will give you acre feet per month. Convert the inch into feet. Now, what question to do? We have two quantities which have volume over mass, and another one is just depth over mass. How to work with that? We can't work with two different types. 1.3 inch per mass, that is just depth per mass, that is not the volume per mass. Is there any way we can convert depth into volume? volume? What is the way? Or is there any way to change F into volume? Square like multiplied by the area, right? You would have any area on which all the water is going on. Do we have any area here? Exactly. So multiply that 300 acre with 1.3, that will actually give you the volume over time, right? Let's do that. Asking question if you have any. The lens or something?
Yeah, I just switch back and forth.
Oh, okay. That's better.
So normally I could see a lot better up close without my glasses on.
Oh, okay.
So usually if I'm like reading or doing something like that. I can still read it.
You got anything close to 6 or something? That is actually the correct answer. 5.46 inch per month. Anyone got anything? Any right from any number in inch per month? Okay, so I will write down one more line. We still have kind of 20 minutes. So anyone has any number for this one? What is that number? Okay, give me one number at a time.
5, 1, 8, 4.
Okay. Now, since we have acre feet, what is the conversion factor? 1 acre equals to 43,560 feet square, right? That means I need to divide that by 43,560 feet square to get acre feet per month, right? Now, as I said, 1.3 inch is just the depth, but I need what? 300 acre, 1.3, I can't work with inch here, so divide by 12 feet per month minus 15 acre feet per month. Now, if you look at all the units, they are in the same unit now, all the quantities, acre feet per month. You see that acre feet per month, all the 3 units, they are in acre feet per month. Now, your task is you will give me the individual, like the final number for this one, and this one. Okay. So I'll write down that, and then if you just find the final number, that's it. So 5,184,000 over 43,560. What is that number? 119. Okay. Oh, everyone's done up to this point. Okay. Okay. So E equals to what is that number? 119 acre feet per month. What is the next one? 1.3 multiplied with 1.3 over 12, 32.5 acre feet per month. And what the very last one was already 15, right? Okay, so what is the very final number? $136. I think that should be one more digit, like maybe you forgot to multiply with 10 or something like that. Actually, it's 100. Oh, yeah, you're correct. So it will be 100. What did you say? 100? Yeah, you're correct because it's on. Yes. So if we convert the feet into inches, that's the time we will get. Okay. But if you read the question, what is the unit they're asking for? Inch per month. So 136 divided by 12. Oops, I don't need this one. Acre inch per month. Now, what we will do about this acre? We don't need acre. Divide by the control volume. That's the exact thing we will do. So 12 over 300 inch per month. Okay, now what is the answer? Yeah, that's the answer I got. Inch per month. That means from that lake, each month, they are losing 5.46 inch of water. That at least that amount, like that depth of water from a lake every month. That is a huge reduction, right? Okay, so all of you got 5.46, everyone. You understand how to change the units and everything. And there is no right wrong sequence. You can do it any way you want. Just if you are a little bit strategic, that will just save you a little bit time. But other than that, you can convert everything into inches. You can convert everything into feet. It doesn't matter. At the end, you will again come back on inch per month, right? Okay. So that was class example 1 and 2. Now, I have